Welcome to today's talk on managing Quorum Queues at scale. My name is V. I'm a software engineer at RabbitMQ, and over the last year, I have led the effort to support Quorum Queues in RabbitMQ. We are a bit late to the party, but we made it eventually. And yeah, throughout the process, we have learned a few things, and then also faced a few challenges that we identify and help improve upon. And today I want to share some of that with you. There we go. So in today's talk, we'll be talking about membership management, health check, and then recoveries. But before we go through that, I want to just mention a few challenges that we face at Amazon, because it will set the context for the rest of the talk. So first of all, at Amazon, we operate at a pretty large scale. The implication of this is mostly that the failures that you see pretty rarely, once every 10 years, actually happens quite frequently at our scale. So the impact of that is that we want to automate the recovery as much as possible. So if there's anything that we can automate, we will try to do that. And then the second challenge that we face is that we operate under a shared responsibility models, meaning that Amazon will be owning the infrastructure side of the RabbitMQ deployment, and then our customer will be owning the application side. So what this means is that Amazon MQ does not have control over the application, and just as a result of that, we cannot make assumptions about what the application will be like. There are actually a wide variety of use cases that we see in our service. So let's start with membership management. Just a quick recap on Quorum Queues. So Quorum Queue is now the default queue type for any use cases that require highly available queues. And it is built the way that it's achieved this is because it's built on top of the Raft consensus algorithm. There are a lot of things that we care about. There are a lot of things in the Raft consensus algorithm, but there are two main things that we care about, me as an operator care about. So the first one is that Raft favor consistency over availability. So in the face of network partition. So what this means is that when there's a network partition, you don't need to worry too much about what's going to happen, whether there's a split brain scenario where you have two partitions dealing with making decisions on their own. You don't need to worry about that. So that's very nice. And the way that Raft does that is through the majority voting mechanism. So the way majority voting works is that, let's say you have a 3-node cluster like this, and you have Q1 replicated on all three. It's okay if you in order to make any kind of progress or decision, you need the majority votes. So either node 1 or 2 or 1 and 3. And thanks to this, it also means that if you lose a node, let's say if you lose node 3 here, your cluster, your queue is still available. Or conversely, let's say if you have a network partition cut off over here, the majority can still make decision on their own, and then the minority will just not making any decision at all. So now let's say that you have a node failures. Let's say that node 3 is just die. For example, some hardware failures. Now in this case, thanks to Raft, the majority part is still operational, and your queue is still available. However, it is no longer fault tolerant. So if any of the other two nodes now fail, then your queues will become unavailable. So what we want to do in that case is obviously you want to replace node 3 with another node. And the way that an operator can do that is by running the following commands. You need to manage the nodes by removing the old node, adding the new node in, like node 4 in. And then you also need to manage the queue members by using the RabbitMQ queues command. There are actually like 2 ways you can do it. But either way, you need to manage the queue members after adding the nodes. Now, if you remember, we said that like this type of failure is actually pretty common at Amazon. So we want to automate this as much as possible. Luckily, the node membership type of thing are already automated through the peer discovery. And there's like, various peer discovery plugins that you can use for this. However, for the membership management, there's nothing at the time that we started looking at this. So we went ahead and contributed a feature into RabbitMQ 3.13 called continuous membership reconciliation. The way this works is that you, like as a user or an operator, you would set the target group size. Let's say you want to have replication on 3 nodes. And then RabbitMQ will automatically maintain that group size for you. So it will do that like by running a reconciliation process either when a node joins or leaves the cluster, or like just like periodically, just in case the trigger doesn't work correctly. And in order to turn that on, you just need to set this configuration line, just enable equal to true. And then you can also like set the target group size in the configuration, but you can also set it through a policy. A policy is a bit more flexible, actually, because you can say like Q1, 2, 3 have higher priority, and like I want it to replicate on 5 nodes, or something like that. That's possible in a policy, but not a configuration. So this is how you would automate the queue membership management in like RabbitMQ 3.13 and up. Yeah, so that part is about membership management. Now, what about health check? When we manage Quorum Queues, is there anything special that we need to care about? So the main goals that we want to like achieve is to answer the following questions. So are my queues currently available? And whether they are like fault tolerant. Like maybe they are available, but they're not like fault tolerant anymore. So and also like one reason why we want to separate these 2 scenarios is because they have different severity in our view. So like if the queue is unavailable, we want to like act on it as soon as possible. But if it's just not fault tolerant, then we can have like a bit of delay before we act on it. Like we don't want to wake up somebody in the middle of the night for that. One thing that you also notice is that we're not like, we don't care too much about consistency issue here, because we know that Quorum Queues is built on top of Raft, and then RabbitMQ already have a lot of tests for like consistency issue before any release. Yeah, so in order to check for queue availability, the first thing you want to check is the node health, because your queues run on the node. If the nodes are unavailable, then your queues are unavailable. So you can check like whether the nodes are running. You can check like system resources, network partition, etc., etc. There are a lot to cover here, but I'll keep this short because I want to focus more on the Quorum Queue specific content. So the first thing you want to use is the Quorum Critical Check. So this is built into the RabbitMQ queues command. So essentially, this is trying to answer the question, will my queues be okay if I terminate this node? And by terminating, you mean like shut it down and then take it out of the cluster altogether. So for example, I have 2 examples here. Like if you have 3 nodes that's running normally, and then you ask, is my node Quorum critical? It's going to say no. So it's okay if you shut down one of these nodes and your queue is still available. But if you just have like a cluster or like a group with 3 members, and you run that command, it's going to say, no, don't shut down the members or the node, because it will like make your queues unavailable. But like while testing this out, we noticed an issue is that when a new member is joined, this command does not consider that members correctly. Like it thinks that the new member is actually a full-fledged member, but this is not true. because in order for like majority voting to work, like the member need to be up to date to the leader, which means that like for a new node that just joined the cluster, it's not like it hasn't caught up to the leader yet, and like in that case, it cannot like cast a vote. So if you like believe the result of quorum critical check and you terminate, say, node 1, then at this point you have only node like 2 and 4 left, and your queues will become unavailable because node 4 is not eligible for voting at that time. So this is problematic. So in order to solve that, we introduce a concept called a voter status in this command. Well, a voter status in like RabbitMQ, and then this command will use the voter status. So the way it works is that when a new node joins the cluster, it's not a voter yet, and it will be considered like just like a promotable state. And then after it caught up with the leader once, then it will be considered a voter, and quorum critical state will actually like consider it a legit member. So now with the new feature, you can turn it on using like this feature flag. Now with this new feature, if you ask like RabbitMQ, hey, this is node 1 and node 2 quorum critical, it's gonna say yes, please do not shut them down. But if you ask like ask it on node 4, like you say it's okay, you can shut down node 4 because it doesn't affect your queue availability. So yeah, this is another feature that we added to RabbitMQ. Now, quorum critical check is pretty nice. It tells you whether you should shut down a node or not. However, it does not like cover everything that you might care about. So for example, it doesn't answer the question, is the group size correct? Because imagine like if you have like a 5 members group, like you want your queues to be replicated on five members, but it only replicated on 4, and you ask like quorum critical, it's gonna say it's okay to shut down any of the nodes. So it doesn't meet your fault tolerance requirement, but you don't know. And then the other questions that it like quorum critical doesn't answer is that whether your queue is currently unavailable or is it just like not fault tolerance. So like if you remember earlier, like internally we want to know the difference between the two because unavailable is a lot more severe than just like not fault tolerant. So in order to answer these questions, you can like move over to the management API. They have like a very nice set of attributes that can help us monitor the state of the queues. Specifically, like the state field, which can tell us whether the queue is currently available. So there are 3 different values that state can take: running, minority, and down. So only running means that the queue is available. The other states mean it's not. And then there's also a members list. This will tell you like the list of all the members that the queue has. And this, like using this information, we can answer like, is my queue having the right group size? And then lastly, there's also a list of online members. And using this online members list, you can tell whether your queue is like fully available as you intended, or is it just like barely available, like 2 out of 3 nodes online. Yeah, so with that we get a lot like better monitoring on quorum queues. However, there's still one scenario that we want to consider, which is what if the member is online, so it's running, but it's actually not syncing. Now, the reason why we're concerned about this is that we see this pretty frequently in classic mirror queues. Like you see a member that is part of the group, but it never tries to sync with the leader at all. So yeah, we look into this, and and in the context of quorum queues, this is also important because in order to cast a vote, a member needs to be up to date with the leader, right? The same problem with the voter state kind of thing. But if your member is stuck, it means that it cannot vote and it's effectively offline. So we want to monitor for this use case as well. And in order to monitor for this, we can turn to the Prometheus API, which provide a few graph metrics. And the main ones that we care about are the apply index and the commit index. So apply index, you can understand it as like this current members index. And the commit index is the leader members, like approximate index. Now, when I say index here, like it's related to the graph log. The way that Quorum Queues replication works is that it replicated based on log-based replication, and then the leader will be appending new entries to the log, and then like the follower will just like try to sync from the leader. So, and this index number is always like increasing, like monotonically increasing. So in order to check for a stuck member, well, the first thing we check is that the apply index doesn't change. Like it doesn't change, it means it's stuck, right? But then we also need to account for the case where the member is already up to date with the leader. And then it's just like the leader doesn't change, so this member doesn't change. So we add another condition that say, we only say that it's stuck if the apply index is less than a commit index. So yeah, this is like, the logic is pretty simple, but it's useful to detect this case. Yeah, so that would conclude the health check sections that we perform for Quorum Queues. So just a quick recap. We recommend doing health check, node health check for your cluster, and then use the Quorum Critical. It's like a very simple and effective tool. If you don't have like all the other ones, make sure you at least have the Quorum Critical check whenever you do anything important. And then yeah, like you can also do queue health check using like the management API state as well as the metrics from Prometheus for stuck members. Now moving on to the last component of managing Quorum Queues, which is recovery. So now that you have all your health check in place, what happens if like you get an alarm like your queues is unavailable? So I'm going to like list some of the mitigations here. Like they are from our experience operating RabbitMQ over the last couple of years, but it's mostly like related to classic mirror queues. Like for Quorum Queues, we did some testing, but haven't seen a lot of production adoption. So some of these, like we're not exactly sure how useful they are. But yeah, here are the mitigations that are not like listed in any particular order. So depend on what the problem is, you can either say restarting RabbitMQ application, but then make sure that you put your node into maintenance mode, or like in the CTL command is called drain, like RabbitMQ upgrade drain. Yeah, so putting a node into maintenance mode will help like cut off the connection, make sure that your node is more stable before you do the restart. And then you can also like add or remove a member. So this is useful, let's say if your members are not like, the group is not at the correct size. But yeah, make sure to use the Quorum Critical check. And then in a really bad case, maybe you want to replace a node. If that's the case, then yeah, make sure to use both of these check, like check Quorum Criticals as well as putting node into maintenance before you do this. And then lastly, you could maybe queue the queue process. When I put this this bullet point up, my colleague, who is a lot more familiar with RabbitMQ codebase, told me to put like a note saying that this is an unclean shutdown and it might not work. So yeah, tell people to be careful with this. But like for classic mirror queue, we find this actually pretty helpful. It's kind of like putting a bandage over a big wound, and it's not solving the real problem, but maybe you want to use it depending on your specific situation. And if you get into a case where you actually lost the majority of the nodes, like these are like very, very bad cases. If you permanently lose the majority of the nodes, it means that you basically lost your Quorum Queues, because if you remember, Quorum Queues uses majority voting even when you try to add a member. So if you permanently lost the majority, you cannot add a new member in, you cannot remove an old member. So it's a really bad case. So luckily, the RabbitMQ core team already thought about this and added a feature to force shrink the member. So this one will bypass the majority voting. But this is like very powerful and very easy to get wrong. So that's why it's just an internal command. So yeah, you can run this command using RabbitMQ eval to like force shrink the quorum queue down to a single node, like bypassing majority voting. Yeah. And then in the event that you actually lost all of your nodes, in this case, unless you have backups beforehand, you are done. Like you lost your data. So yeah, make sure to have backup if the data is important to you, and yeah, have runbook like prepare beforehand on how you would like recreate a node from backup. Yeah, you don't want to do this in the last minute, like when you already lost all the nodes. Yeah, so that is like all that I want to share today about managing quorum queues at Amazon MQ. And just a quick recap. So we talk about like membership management, which I recommend like using like continuous membership reconciliation if you don't want to manually manage this yourself. And then for health check, we talk about like monitoring the node and queue health checks. There are various things that we want to look into. And then for recovery, yeah, be prepared. Like know the tools that are available to you and use your best judgment to take the right action at the right time. Okay, thank you.
All right.
Hi, thanks. Ooh, that was a great talk. Testing and, I guess, model verification. So these are distributed systems. There's all kinds of race conditions that could happen. What kind of testing do you do? Do you do any scenario testing, etc.?
Yeah, so for formal verification, we haven't built a model for RabbitMQ yet. Like I did talk briefly about that, but eventually decided that we should be doing like the thing that are usually most. Okay, they are the testing that RabbitMQ already does. Because I look into it and I think RabbitMQ run a Jepsen test suite. Okay, yeah, like we confirm. Yeah, Jepsen test suite, which is testing like various failure scenarios for the RAF consensus algorithm. So like termination, like network partition, and then just those kind of things. So and then when we were working on releasing this, we were most concerned about customer usage pattern because we're supporting like a wide variety of customer usage patterns, and we want to make sure that quorum queue is stable, meaning that if customer try to overload their own broker, they will not be able to like fail it over. And then cause problems. So we did a lot of testing on like different usage patterns, especially like the problematic kinds, like a lot of high connections, a lot of messages, a lot of queues. So those kind of things. We found a few problems in quorum queues through this test, and yeah, reported a couple of them, got them fixed. Yeah, so and for the consistency type of thing, we rely on the open source test, the Jepsen test suite.
Yes, great talk. Thank you. In some of our testing, in a very rare circumstance, we found that a quorum queue had no leader. Mm-hmm. And the critical test would pass, but there's no leader. We were unable to force an election. The only way we could get it back is to delete the queue and then redeclare it, and then it was fine. But have you ever seen a quorum queue with no leader? And if so, were you able to recover it?
So one interesting case that we saw in the past is where if you overload the cluster heavily, and then like CPU is like 99% on all 3 nodes, and then you try to terminate a node, what could happen is that the metadata within RabbitMQ and the data within Raft are not synced together. So this member is still part of the group, but like it's actually gone from Raft point of view. And what happens in that case is that yeah, I think what happened in that case is the metadata that you get from RabbitMQ is just like not correct anymore. Yeah, but I'm not sure if it's the exact same case. I kind of remember I didn't check the leader status at that time. But yeah, like for that issue, like the fix was basically just like syncing the metadata from Raft back to RabbitMQ metadata. I kind of suspect that your issue might be similar, where so like Raft is very well tested, but then like RabbitMQ, like Quorum Queues using Raft is not as well tested. So like the integration point between the two might be like broken somewhere. So yeah, that's just like my guess. I don't really.
Yeah, that would be my guess too. Yeah. Yeah. Any other questions? If not, oh, yes, I see a question.
Yeah, so you mentioned that when you add the queue, now there is this new feature that it enters as a non-voter and does not count against the check if node is Quorum critical. But what happens if you don't modify the membership, just stop a member, wait for an hour and start it? It's completely out of sync. So until it syncs, is that a voting member? Does it count as a Quorum critical? How does it behave, and could it be improved, or do you use other checks in this case?
Yeah, that's a good point. Yeah, so one thing I should have noted is that the voter status is a permanent status. So once a node first join, it's not a voter, but once it caught up once, it will become a voter and it stay a voter forever. So in the scenario that you described, where a node pause for a long time and then it start back up, it will still be a voter, and then Quorum critical check will still like saying okay to terminate the other nodes, but it's not really right.
Yeah, it would still be a voter, but it wouldn't be eligible to become leader, is sort of what happens. It can't get elected leader because it's behind.
Yeah, and like to one thing that I think you're alluding to is can we like perform this check again? Like, can we like continuously check whether a member is like maintain its voter status, like whether it's up to date to the leader? Towards this end, I think we could potentially re-trigger the voter status check periodically, but that's like still like depends on discussion with like further implementation.
Okay, final question.
All right, I have to choose because I had two. But I guess I'll choose to ask about the maintenance mode that you apply when you restart nodes. I would expect that RabbitMQ CTL stop would be nice, that you wouldn't have to do anything additional before shutting down a node.
Yeah, I think that's a legit point.
I would still recommend going in maintenance mode. First, maintenance mode makes it ineligible to be elected leader, and so it won't become a leader if there's a Raft election while you're waiting to shut it down. And so, yeah, it's just a generally better idea first.
Yeah, also maintenance mode will block new client connection to the node.
Yeah.
Yeah. Okay, thank you everyone.